Hey, so today we're gonna be working on stuff like this. Okay, you got three equations, each with three variables. So 3 by 3 equations. So these look very scary, but there really isn't that much more to them than two equation, two variable stuff. So I got my notes over here on paper. So one thing I like to do here is I like to insert a table. Just make it like 2 by 1. So not because, and you'll see why. So basically, we gotta look at these equations. All right, so we got 2x minus y plus z equals 4, x plus 3y minus z equals 11, and 4x plus y minus z equals 14. So what I notice is that these z's, they're all isolated, and one of them is positive, and two of them are negative. So we're gonna put this equation in to the table, both sides, and then we're gonna put each one equation under each. So I'll put this one underneath here. So I'll just copy that. Put that one under there. I'll put this one under here. So let me solve with elimination. Okay, we're doing this with elimination. So let's add them. So this would be 2x plus x, that's 3x. Negative y plus 3y, that's plus 2y. The z's cancel out. And so that equals 4 plus 11, that's 15. Over here, the solution, let's see. So we got 2x plus 4x, that's 6x. Would you look at that, the y's also cancel out. So 6x actually just equals 14 plus 4, that's 18. Equation of Cantor substitution. We actually get x out of this. So if we divide both sides by 6, x equals 3, so we have x. You guys following along so far? Good, hope so. So we have x equals 3. So now, let's apply actual into this equation here, since it's two variable equation. So whenever you have one variable solved, you should plug it into a two variable equation, because then you'll solve one of the variables and you'll have the answer to the other variable. That's pretty cool. So let's plug this in. So 3 times 3, that's 9, plus 2y equals 15. Move some stuff around. So let's see, 9 makes negative, so 2y, equals 6. Simplify that, y equals 3. Alright, now we have two variables, so we gotta take one of these three original equations and plug it into that. So I think, I always go with the one we put twice. So we'll plug that in. So we got 2x, so x is 3, so we got 6. Alright, minus y is 3, so minus 3. Plus z, we do not have that solved yet, we're talking for that. Equals 4. Move some stuff around, z equals, alright. 6 minus 3, that's 3. 3 moved over here, so 4 minus 3, that's 1. And z equals 1. So your answer, if you want to put it in point form, is 3, 3, 1. Or you could just say, x equals 3, y equals 3, and z equals 1. That's how you solve that one. Let's just do one more example here. Okay, so let's look at these. Again, all my z's are isolated, and we got a positive z and two negative z's. So we're going to insert a table. Bam. Okay, let's put this top equation in twice. So this equation, copy it in. It won't always be the top equation, people, okay? Just look to see if there's isolated variables like the z or the y or the x, and see if like one of them's positive and two are negative, or one's negative and two are positive. And whatever is the minority, you put that twice, and then you subtract the other equations from them. So back on track. We got this. We'll put this equation underneath, alright, of this one, Kobalamo. And we'll put this equation underneath of the other one. Pow. Alright, let's solve over here. 2x plus x, that is 3x. So we got negative 4y and 5y, so that would just be y. Oh, plus y, because it's 1y. The z's cancel out, and we got equals 6 plus 7, that's 13. Let's solve over here, alright. X, 2x, that's 3x. Alright. Negative 4y minus y, that would be negative 5y. Okay. These cancel out, so that equals 6 plus 1, that's 7. Alright. This would actually be a good one for the different step 2. Alright. So we'll take this one, and we'll actually eliminate it from this one. So let's see. We can probably just multiply this one by negative 1. Make the x negative. So then we'd get negative 3x plus 5y negative 7. Okay. So let's do that. So we got this one and the one below it. So x cancels out. So we got nothing so far. Y plus 5y, that's 6y. 13 plus negative 7, that's 6, so equals 6. Which y equals 1 if we divide both sides by 6. We got y. Let's look at, we'll do this one. Plug it into here. So we got 3x plus y is just 1, equals 13. Let's simplify. 3x equals 12. X equals 4. See what I did there? Okay. So 1, so 13 minus 1 is 12, and then divide both sides by 3, we get 4. So let's plug this into one of the original equations. Okay, let's plug it into this one like I usually do. Okay, so x, that's 4 minus 4y. That's just 4. Plus z, we're solving for that, equals 6. Move some stuff around. Okay, 4 minus 4, that's 0. That cancels out, so just z equals 6. So yeah, that's your answer. So point form, let's put it in point form, alright? So we got x is 4, y is 1, and z is 6. Or you can just put x equals 4, y equals 1, and z equals 6. Alright, if you want to solve a substitution, I'm not even going to show you that. Look up this video here, Mario's Math Tutoring, 3 rails, 3 equations, solving using substitution method. 5 minutes, explains it so awesomely. Highly recommended. I'm not even going to try to do better than this guy. Just watch this video and you'll understand. Have a great day. I really hope this math helped you, okay? I really do.